Good morning. Just wanted to share with you guys some stuff about what is it, 11.1, I believe. Yes, it is. Starting a new unit here, getting you guys set up to do some right triangle trigonometry. There are some key concepts here, and they focus around both surface area and volume of particular figures. We're going to look at specifically cones. Oops. Let's try this. Cones, pyramids, and spheres. I would assume that most of this is a bit of review. In geometry, you guys had this information and it was presented to you along with prisms and I believe cylinders. The focus is not on those particular three-dimensional figures. So prisms and cylinders are left out of this, I believe, at this point. Now, oh, they do have an application problem with, looks like a cylinder when I'm looking at it here. Regardless, I guess we'll look at that when you come to it. So let's just do this. The first thing you need to do is be able to identify the key, I guess it would be some key features of each of these types of figures. First of all, drawing them is also helpful. So I just kind of want to take you through the drawing first, and then we'll refer back to some of those key features. So one thing for sure is being able to draw just on like an ellipse or, an oval, so to speak, and it doesn't have to be anything elaborate. And then, and again, all of these are right. They're called right ones because they are both right cones and right pyramids. They are parallel to their base. So when I say they, it has to do with their height. So first of all, just draw an oval, and then kind of straight up about the middle of that oval, you're going to draw a point to make a cone. And then you just draw lines down from that point. And this is hard to do. Obviously, you can see that when we're doing it on. All right, let's try that again. So you want to draw it from edge of that oval up to what is called the apex of this cone. So this is one of the key features of both a pyramid and a cone, is that top point that they both come to, and that is called an apex. All right. Now, as far as a pyramid is concerned, pyramids take on several different forms, and those forms are based upon whatever their base is. So let's just go back to a cone real quick. The base of a cone is a circle. The base of a pyramid is going to be some kind of polygon. So it could be a triangle, a quadrilateral, and any of those types of polygons, pentagons, hexagons, whatever. The number of sides creates a pyramid. So let's just do this. Let's start really basic here. Let's go with a pyramid that actually has, hang on a sec here. For some reason, my brain is halting. Make sure. Okay. So when we draw a pyramid, we kind of want to squish down our polygon. Let's say we're going to do a triangular pyramid that looks like that. So all I've done is I've taken a triangle and I'm just making it an obtuse triangle. And then I do the same thing. I draw a point above, and this is again creating that apex. And so once I've created that apex, I draw from the edge up to, when I say the edge, I guess the vertices, each vertex there of that triangle, draw that up to that apex. So that gives you that idea of polygon. Sorry about my dogs here this morning. They're all active now that I'm out here doing this. Of course, they were just sleeping, and now I do this, and then they get all fidgety. Anyway, sorry about the sounds in the background. Those are my dogs flapping their ears. All right. And then a sphere, again, we're just going to create an oval. And then from that oval, we just draw a little dome above and a dome below, and that gives the idea of a sphere. All right, so each of those figures have key components. Let's look at some of those. I'm struggling here this morning because I'm using two different programs at the same time, and they both have writing tools, and so one's writing over the top of the other. All right, so disregard that line right there. Maybe I can erase that real quick. Maybe it'll let me. Nope, it's not letting me. I'm just creating a bigger mess. All right, so disregard that line that's there. Many apologies. All right, so let's look at key features of polygons, or excuse me, of pyramids and cones specifically. There's this thing that is called slant height. And think of that as the side. So that slant height is the side of your pyramid. It's slanting up to the apex. So it's coming from that base up to the apex. So there's slant height. And then there's just regular old height. And this is highlighted in the text as well. I would just take Mike's examples here that I'm giving you, and then when they start applying these problems, maybe refer back to this or back to the book. You do a good job there. All right, so let's do this. Let's make another cone. So we're just going to make a little oval. We're going to have that go up here, and then let's point out some of these key features. So, and a lot of times you're going to see dotted lines. So this representing from the center of the base, the circle, all the way up to the apex is going to give you the height of that cone. The same could be said about this pyramid above us. We go to the center of the polygon base and we dot it up there. And by the way, my dot is going to disappear because there is that back edge. So if you kind of turn the triangle, and I'll show you how to do that here in a sec, you'll see that height as well. Okay, and then the slant height. What is the slant height? Well, in a cone, it's just the edge that runs from the base up to the apex. So anywhere on that surface around the slant, think about that, slant height, is giving you that measurement. Lo and behold, just know that if you were to draw from that point along the edge out to the center, you're actually creating a right triangle. So on the inside of these figures, there's a whole bunch of right triangles. And anytime you have a right triangle, you're going to obviously be finding measurements of that using Pythagorean theorem. So just know that Pythagorean theorem is also going to be part of this whole thing. So your ability to be able to draw on all your past geometric experience is going to come into play here. So the Pythagorean theorem, a squared plus b squared equals c squared within your right triangles, that's going to help you find key features within these problems. All right, so let's point out what the slant height would be up on this pyramid. Now, it's kind of counterintuitive. It seems like, well, shouldn't it just be the edge? Well, it's not. It's not the edge. The slant height is created in the midpoint. So the midpoint of that edge piece up to the apex, that's going to be your slant height. So in that pyramid there is your slant height. All right, I'm going to do another example of this, and you can try this yourself. I would strongly urge you to do some of this on your own. Try to make some drawings on your piece of paper. If you've done this before, it shouldn't be a big deal for you. But let's try this. I'm going to show you how to make kind of an offset square pyramid, because that allows for you in that pyramid to be able to draw some of these key features. And so I kind of offset it a little bit. And this is definitely not going to be perfect here, but you'll get the idea. So this, we're trying to communicate that this is a square base. So one thing you can do is draw a little point in the center, close to the center, and then straight above it, like 90 degrees straight above it, you would draw your apex. And now you can draw the pyramid. and you're trying again to communicate that this pyramid is square. So we could just do this. Like we can say, well, this side's X, this side's X, and each of those are all the same. Okay, so those lengths are the same. And, assume that these things are right angles in the base. All right, so we can dot, dot, dot. Our height starts kind of getting a little bit, so we'll call that H. And then you can also show, say, the slant height. So there is what is called L, the slant height. So just know when we see L, slant height, H is height. And then base edge, in this case, would be like X. I'm giving these letters because soon all your formulas are going to come from this. All right, so pause the video. Try to do something just like this using both a polygon base and a circle base. So make a pyramid and a cone of your own. Here, I can show you how to do a hexagon one real quick. I'm not going to do it, but I'm going to draw the base for you. So if you do a squished down hexagon, and that's not pretty, doesn't have to be, squished down hexagon, you can create your pyramid that has a hexagon base. All right, so pause the video, try it with both a cone and a pyramid. All right, welcome back. Hopefully you spent some time doing something like that. I'm going to show a cone also that can be inverted. So guys, it really isn't much more than that. I'm going to show this hexagonal pyramid. That's how you would say that. Just draw it up there to that point. We get a whole bunch of stuff going on there. Sorry, again, doing this remotely, not fun. So that shows that you got this hexagon. And these, we could say, well, this is a regular hexagon down here. So we're going to say all these side lengths are X. And it allows for you to be able to find surface area and volume, because that's where we're headed. All right, guys, I'll see you in the next video. We're going to actually do a couple of examples with this where you're having to find both surface area and volume. You're going to rely heavily upon your book, specifically on the top of page 473, because they give you the formulas and ideas around being able to find both surface area and volume of these figures. Again, page 473, I'm going to highlight some of this with you. You're going to want to write those into your notes so you can refer back to. All right, see you in the next video.